Hey folks, I've got an example for us of work and energy with using constant forces. So we have some constant forces acting on our 10 kilogram block. And so I've got a bunch of data there that you might want to pause the video and write down. So we have a block. We got two horizontal forces acting on it. There's vertical ones too, but we're going to ignore that for now. Block goes 5 meters. There's a starting and final kinetic energies are given. And we're going to determine the following. V naught, V final, net work done by F1, work done by F2, the force of F2, like what is it? The power that F1 is delivering to the book at the end of the motion, and the power that F2 is delivering to the book at the end of the motion. So again, if you need a moment to copy all that down, please make sure you pause the video and do that now. All right, so the first thing is V naught. Well, I've given you the mass and kinetic energy of the book. So for V naught, okay, all we got to use is K equals 1/2 mv squared. And solving for V, we get root 2K over m. And that is root 2 times 50 over 10. So that is root 10, which is about 3.16 meters per second. All right, so there's V naught. V final, you would do the same thing for. I'll do it over here. So V final, same equation. The only difference is instead of a 50 joules, we have an 80 joules in here. So you get root 16, which, hey, is 4 meters per second. Okay, so there's our V final. All right, net work. Well, you might be wondering, well, how are we going to figure that out if we don't have F2 up there? Well, it turns out that we have all the information we need because net work is change in kinetic energy. Our starting kinetic energy was 50, and our final kinetic energy was 80, and so the change was 30 joules. So look at that, easy, okay? Now, how about the work done work done by F1, okay? So the equation for work done by a force, the most general definition is F as a function of R dot dr. For us, we have forces in the x direction, so I'll write integral of F of x dx, okay? But in this case, we don't have to integrate because the force is constant. It's 20. So you're just integrating 20 dx, which turns into, what's the integral of dx? And you evaluating it from x naught to x final, it's simply delta x. In other words, you're using force times distance here, okay? So the work done by this guy, force 1, is 20, and delta x is 5. And the answer is positive 100 joules. Now, the reason I put the positive there is the force is to the right and displacement is to the right. So when the force and displacement are in the same direction, you get positive work done. Now, what about the work done by F2? How are we going to figure that out if we don't know what F2 is? Well, we do know that the net work is 30. And the net work is simply going to be the work done by force 1 plus the work done by force 2. We know that's 30. We know this is 100. So the work done by F2 is negative 70 joules. Now, does that make sense? Why are we getting a negative? Well, it's negative because it's pointing opposite the motion, and the math actually gives us that negative answer, which is great. Okay, now the force F2, okay, is pretty simple. We know, and I'm not gonna do the whole integration thing again. We just know that for a constant force, work done is equal to force dot delta x. So I'm not going to reintegrate it, but that's what you get. So we have a negative 70 equals the force, which I don't know, and delta x is 5. And you get a force of negative 14 newtons. And it's negative, again, because it's acting opposite the motion, so the math tells us that. And then the final thing I asked you for was the power being delivered by each force at the end of the motion. So I'm asking you for the power at an instant in time. Therefore, I'm asking you for instantaneous power. So power, instantaneous, is force dot velocity. And I'll write instantaneous here. Okay. So for one, the force was 20, and the velocity at the end of this motion we calculated to be 4. So the answer is 80, and the units for power are watts. And it's positive. The positive means that you're adding energy. That force is adding energy to the block at a rate of 80 joules per second. And then the other one, for force 2, would be negative 14 times 4, which is negative 56 watts. And the negative means that this force is sucking energy out of our block and turning it into something else at a rate of 56 joules per second. Overall, the total power is positive, so our block is still speeding up. All right, so I hope that example is helpful, and thank you very much.